first invitation to the next week. So we will have a special guest, legendary Stuart Kaufman, who will have a talk body, mind, and quantum mechanics. So I believe that all of us will understand everything. So come and see somebody really legendary. But today we have another task, so I would like to welcome Pavel Flegontov, who is a rare person who could speak about proteins, parasitology, whatever, but he likes also human genetics and he is working for some time in Ostrava, and he came to tell us something about peopling of America. So welcome.
Thank you.
Happy to have you here.
Okay, good evening, everybody. I've started my own research group in the University of Ostrava 3 years ago, and since that time I've been working on genetic anthropology. So in this talk I would cover the following topics: general picture of America's settlement according to the results from the fields of archaeology and genetics. Then I would focus more on the prehistory of the American Arctic, because that's what I'm most interested in. And I would briefly overview the tools we are using in our research, because they are not widely used so far. And then I would talk about the application of these tools for studying the prehistory of a certain American language family, which is important from several points of view and still remains controversial. So again, I'm working in genetic anthropology, and our ultimate goal is to build an interdisciplinary picture of human prehistory. So I prefer to say that I'm studying prehistory, and that's a picture you probably all know. A current view of two competing hypotheses on the movement of Homo sapiens out of Africa. The blue route of one wave of settlement and the red routes of two waves of settlement. And these results are usually obtained using two types of data, either multi-locus bi-allelic SNP data, which are obtained from SNP chips or SNP arrays, or now more and more from NGS, from whole genome sequencing using high throughput sequencing technologies, mostly Illumina. And then various flavors of biallelic SNP data are used for various methods, either SNP loci which are in linkage equilibrium, which are unlinked and inherited independently. There are special computational methods for filtering linked loci with correlated allele frequencies in large data sets. And but for some other methods, linked SNP loci are used on the contrary, and relatively stably inherited autosomal haplotypes are inferred from the data, and then individuals are compared based on these haplotypes. And recently, a novel class of methods appears which operate on very rare alleles which occur at a frequency of less than 1% in a population, in a global population. And still data on mitochondrial and Y chromosomal haplogroups are widely used, but for some purposes they are much less informative, but on the other hand they have their own advantages. So let's start with prehistory of America. That's the latest paper that tries to date the first period of settlement of America based on coalescence dates of mitochondrial haplogroups. And divergence of Siberians and Proto-Americans is estimated at around 25,000 years ago. Then specific Native American founder lineages appear around 18,000 years ago, and population expansion in North America probably happened 16,000 years ago. But that's only the first part of the story. Already in 1986, Joseph Greenberg and colleagues has proposed a famous three-wave model of America's settlement based on linguistic, dental, and genetic evidence available at that time. But at that time, genetic evidence mounted to blood haplogroups and something like that. This three-wave model has found some support from modern genetics in 2012 in a Nature paper by David Reich and co-authors. So let's start the overview from the first wave, and then we would talk more about the second and the third wave because they are much later and they were restricted to the American Arctics, to the high latitudes. So the first wave population was actually a mixture of up to 3 groups. One is related to modern East Asians. The other one, it comprises around 30%, is related but distantly to modern Europeans. This group occupied vast areas in Siberia and got admixed with ancient East Asians and gave rise to Proto-Americans. And according to some recent data, there is also a small percentage of ancestry that is related to a population living much further south to so-called Negrito people from the Andaman Islands and to Papuans. So when the Cordilleran and Laurentide ice sheets started to melt, there opened a passage along the coast and maybe a passage between the sheets, and people started spreading from the Bering Land Bridge region southwards. So, and I've mentioned that the first wave was of mixed origin, but probably it was also heterogeneous because this Papuan and Negrito ancestry nowadays is virtually restricted to the Amazon region. Surprisingly, it doesn't occur in Mesoamerica or in North America. It occurs only in the Amazon region of South America. And this picture illustrates a dichotomy of the first settlers, of first Americans, because again nowadays the deepest divergence among first Americans is between populations occupying Canada and all other populations further to the south. And it's not clear where this divergence has happened, whether modern populations of Canada stayed north from the passage between the glaciers and had some time to accumulate drift and mutations, or whether they were isolated in North America, but then there was backward expansion of people from South America or from Mesoamerica. So far it's not clear, but we know that native people from northern North America are very much different from all the other first Americans. And currently there are also discussions about about whether this ice-free corridor was permeable and at what time it became permeable. Originally it was supposed that it became permeable pretty early, around 15,000 years ago, but in a recent paper based on ancient genomics from lake beds, it has been found out that the corridor has likely became permeable only later than 12.5 thousand years ago, and the first dispersal south was definitely earlier. Therefore, people had to take the coastal route and not the interior route through the ice-free corridor. And there are also parallel features in the archaeological record, archaeological cultures, which mirror this movement of genes from Beringia to America. For example, so-called ductile culture, at some point we see that it's spreading in a continuum of related cultures through Chukotka and to Alaska. And apparently it mirrors the first wave of settlement. So here is a summary of what we know about the first wave. So it quickly spread from Beringia southwards around 16,000 years ago, and grouping the first Americans into a single cluster of populations has been supported by modern and ancient mitochondrial DNA and Y chromosomal haplogroups and genome-wide autosomal data. And dating based on these kinds of evidence is usually consistent. As I mentioned, within the first wave, there is a deep split between populations from northern North America and all others. First American ancestors were a mixture of around 70% East Asians and 30% of ancient Europeans, although they lived not in Europe, but in Western and Central Siberia. And there's a good agreement between archaeology and genetics, and grouping of all first American languages into one macrofamily, to one language macrofamily, has been attempted a long time ago by Joseph Greenberg in 1960, and that was followed up by his colleague Merritt Rulin. That has been widely cited but got virtually no support among historical linguists. So although populations of the first wave are clearly related and clearly came from one source, the time depth is too great for any reliable linguistic reconstruction. But anyway, I said they came from one source, but the first dispersal was probably a protracted event lasting several thousand years, when the Bering, until the time point when the Bering land bridge was completely flooded due to global warming. And last year it has been revealed that Native Americans from the Amazon basin, as I mentioned, are distinct from other first Americans living further south or further north. And they harbor additional ancestry, but there is a controversy about what this ancestry actually is, because one paper claims that this ancestry is comes from Papuans and Negrito people. This paper by a very famous group of David Reich, but another paper by no less famous group of Aske Willerslev claims that this is just a broad East Asian ancestry, and they cannot find this particular Melanesian and Negrito signal. But I would not talk more about that. Now I switch to the second and the third waves of settlement. As I mentioned, they were largely restricted to the American Arctic. They emanated from the same entry point because there was only one entry point. And the second wave was represented by several archaeological cultures collectively known as American small tool tradition, and for example the Sakak and Late Dorset cultures. And the third wave was represented by the Thule culture and by present-day Inuit. So let's talk in detail about the second wave and the third wave. We would talk about them together because they are pretty much intertwined. So we know that around 5,000 years ago there was the second movement of people across the Bering Strait, but at this point it has long been flooded. So we don't know whether the people crossed by boats or whether they crossed using the sea ice, but most probably by boat, because at that time point the climate was warmer than at the present, and there was virtually no ice in this region. And they established the first area along the northern Alaskan coast, and then rather quickly spread across the American Arctic. And surprisingly, they first settled the very north of Greenland, which at that point was not covered by ice, and there was not so much pack ice in the sea, because, as I mentioned, the climate at that point was warmer than at the present. And these people are collectively called Paleo-Eskimos. That's a historical name. Actually, as I would talk later, they have not so much to do with modern Eskimos, but this name is the only name we have for these people. They hunted both on the land and on the coast, and we observed that through time they gradually more and more shifted towards hunting sea mammals for example, seals, but they never hunted whales. They lived in tents and semi-subterranean houses, and as wood was extremely rare in those regions, they usually warmed their houses by burning animal fat. Seal, for example, seal blubber was burned in soapstone lamps like that. And they used composite bows, and actually they were first to introduce the bow and arrow technology to northern North America, so maybe because of that they had some advantage over local people and were able to quickly spread over large territory. And they had quite a lot of masks and engraved art and pottery. So apparently they had a tradition of rituals. And what it would be important for our discussion is that they never moved deep into interior Alaska and into interior Canada. There was a long-term cultural boundary between a so-called Northern Archaic culture attributed to first Americans, and which, according to many archaeologists, then smoothly transformed into pre-modern Athabascan cultures, so Nadina cultures, and this ASTT cultures on the coast. And back in 2010, an ancient genome of the Sakak archaeological culture of one individual has been sequenced at a relatively decent coverage between 5 and 10. Actually, I don't remember what exactly was the coverage. But that remains the best quality genome for the whole group until now. Although quite a lot of genomes have been sequenced in 2014, they were very low coverage, up to 0.3. So this genome was sequenced back in 2010 in a Nature paper. Actually, the preservation of ancient DNA was superb, because they recovered a clump of hair from permafrost in western Greenland. And the hair sample was dated to about 4,000 years ago. So these were one of the first settlers of Greenland and one of the first settlers of the American Arctic. And back at that time, 6 years ago actually, not so many of the modern methods we use for autosomal genetics were available. And one of the methods used by the authors was admixture or structure, but they used the admixture software. And here we see an admixture profile of a reference data set. And here's a profile of the Sakak individual. And I would explain now what this profile means. So admixture operates on unlinked genome-wide SNP data, for example, on 100,000 or 500,000 SNP loci. And again, SNPs have to be unlinked, the loci have to be unlinked, and individuals have to be unrelated for this method to work. And the user gives the program a certain value of k, number of hypothetical ancestral populations, to model each individual. So each individual is considered a mixture of certain number of hypothetical ancestral groups. And at the same time, the composition of each individual is modeled, and allele frequencies at each locus in these hypothetical ancestral groups are modeled as well. So in the end we get two matrices, a matrix of allele frequencies in these hypothetical ancestral groups, and a matrix of admixture proportions in each individual. And going back to this slide, we see that these results can be interpreted only in frame of some reference data set, where we see, for example, that Japanese and Han Chinese have up to 100% of the orange component. And we can conclude that this orange component stands for Northeast Asian ancestry, while, for example, the blue component stands for European ancestry, and the yellow component stands for Siberian ancestry. And for example, we see that Russians are modeled as a mixture of around 90-95% of the European component and about 5-10% of the Siberian component, which is close to the truth. And what did the authors find about the Sakak genome? They found out that Sakak has a peculiar composition of ancestral components, that it has around 60% of this light yellow component, and it is shared by ethnic groups of Kamchatka and Chukotka, so we may call this component Beringian, and this bright yellow component, which is typical for populations of inner Siberia, for example, Ganasans and Yakuts. Although there is a caveat that it's very tricky to model ancient genomes using modern populations, because some of the components modeled here might have never existed 4,000 years ago. So actually, in this case, we are simply modeling differential relatedness of this ancient sample to certain modern groups. So we can say that it's closer to Chukotkan and Kamchatkan groups, and a bit further away from Siberian groups, and even further away from Southeast Asian groups. But we can't say anything else. We cannot say that it's actually a mixture of these three populations, although it appears as a mixture. So here I wanted to give some details about this method, but I would skip that. So so far, as I mentioned, Sakak remains the highest quality reference available for Paleo-Eskimos. And Paleo-Eskimos is the only population in America having clear affinity to modern groups in Kamchatka, Chukotka, and moreover to core Siberian ethnic groups like Ganasans, Cats, and Yakuts. So it's genetically distinct from all other Native Americans, whether modern or ancient. In this paper, in 2014, many other ancient genomes of Paleo-Eskimos have been sequenced, but as I mentioned, at very low coverage. So unfortunately, they are not usable for the methods we apply. Let's continue discussing the prehistory of the American Arctic. So there are the following questions. Did people of the Nadina language family admix with Paleo-Eskimos across this stable cultural boundary? And what language did Paleo-Eskimos speak? Of course, we would never know that, but we might try to build some hypothesis trying to merge linguistic and genetic data. And we know that around 1,000 years ago, the third wave of settlement has entered Alaska. It entered again through the same route and apparently by boats. That was the Thule archaeological culture, and Thule and modern Inuit cultures are collectively called Neo-Eskimos. Then around 200, 300 years later, after incubation period in Western Alaska, the Thule culture has extremely rapidly, within a couple of generations, actually according to new dating, has spread very rapidly from Western Alaska throughout the American Arctic and to Greenland. And at roughly the same time, the Paleo-Eskimo cultures have vanished from the archaeological record. And still it's not clear whether there was a mixture of newcomers and indigenous people, Paleo-Eskimos and Neo-Eskimos, or whether there was complete population replacement and basically Paleo-Eskimos have vanished, leaving no trace in modern groups. This hypothesis was advocated in this 2014 paper focused on the on ancient genomes of American Arctic. So again, there's another set of questions. Did maybe Nadine admix not with Paleo-Eskimos but Neo-Eskimos across this boundary? And again, did Paleo-Eskimos vanish without any trace, or did they leave modern descendants? So Neo-Eskimos are currently represented by three broad groups of people: Chukotkan and Alaskan Yupik, Alaskan Inupiat, and Canadian and Greenlandic Inuit. And unlike Paleo-Eskimos, they were very much specialized for whaling, for hunting bowhead whales. And unlike Paleo-Eskimos, they used dog sleds, dog traction, and overall they were they had more advanced technology that was specialized for living in the north. But there's the last chapter in this story, the arrival of the Norse from Norway through Iceland. They arrived around 1980. Actually, according to the latest dating, at that point they could have met only Paleo-Eskimos. It was thought before that they met Neo-Eskimos, that they met Inuit, but actually most probably they met Paleo-Eskimos at that point. And then Neo-Eskimos started to spread 200-300 years later, and then a period of cooling known as Little Ice Age has started, and probably it led to the demise of this Norse colony, and it vanished around 600 years ago. So that's the modern distribution of the third wave people of Yupik, Inupiat, and Inuit. Again, they entered around 1,000 years ago, and then 800 or 700 years ago, they quickly spread throughout the American Arctic. And the last set of questions is, the last question is whether all groups of modern Eskimos had mixed with Paleo-Eskimos, or whether that mixture actually happened, or just some groups admixed with Paleo-Eskimos. And finally, I would like to talk about the internal evolution of the Nadina language family. We know based on linguistic data that Tlingit, a small group of populations now occupying the northwestern coast of Canada, and no, actually Alaska, they occupy Alaska. They occupy the southeastern tip of Alaska. So we know from linguistic data that they split pretty early. We know from lexico-statistical dating that they probably split more than 2,000 years ago, and maybe even earlier. Lexico-statistical dates are precise even more than genetic dates, but anyway, we know that the split was pretty ancient. And probably they always remained near this place. And then around 1,800, 1,900 years ago, there was a volcanic eruption in southeastern Alaska, which covered a rather large area with ash. And according to speculations of some archaeologists, this precipitated migration of another Athabascan group to the Pacific coast where they live today. So I failed to mention that the Nadine language family is subdivided into Athabascans and Tlingit, and Athabascans are subdivided into northern Athabascans, which still live in Alaska and Canada, into Pacific Coast Athabascans, and into another group living in Arizona, which I would mention in a few seconds. So there's yet another branch of the language family, but now it's extinct, so I would not talk about it. So there are two major branches, and within the largest Athabascan branch there are three sub-branches: the northern one, the coastal one, and the south one. And around 600-700 years later, after the first volcanic eruption, the same volcano has erupted again, but that eruption was much stronger, and according to modern deposits of ash around a large territory, we know that it was a colossal eruption. And again, according to some archaeologists, it might have triggered the migration of southern Athabascans from their original homeland in northwestern Canada very far south to the Grand Canyon area. So these are widely known ethnic groups, still numerous, Navajo and Apache, and they started this migration probably 850, probably around 850 CE, and finished this migration probably around probably in the 13th century. And we know that they engaged in communal hunting of bison on the Great Plains. They used to drive bison off cliffs, and in this way they killed hundreds of animals, and they had huge surplus of meat, and apparently traded this meat and its products with nearby farming societies which lived near the Great Plains. So to summarize, the coastal interior cultural boundary in Alaska has existed in the American Arctic for many thousands of years. And currently the Inuit Eskimo Aleut speakers and northern Athabascans Nadina speakers live across the boundary, but Paleo-Eskimos used to occupy the same areas in the past. And I'm interested in this question was the language, culture, and genetics of Nadine, or at least their northern branch, shaped by interaction with Paleo and or Neo-Eskimos. And I've also failed to mention that there's a linguistic hypothesis that unites an isolated language in western Siberia, the Kat language along the middle Yenisei River. It associates this language with the Nadina languages into a so-called Dina-Yeniseian macrofamily. This proposal has been put forward quite a long time ago, but extensively researched and published by Edward Vida in 2010. And here are some dates based on lexicostatistics. So it's hypothesized that the Dana-Yeniseian macrofamily has split from 10 to 8,000 years ago, and the Dina family itself from 5 to 3.5 thousand years ago, and the Yeniseian family from 3 to 2.5 thousand years ago. But I would like to stress that all macrofamily proposals in linguistics are not universally accepted, so there's a huge amount of controversy around this hypothesis, and some linguists consider it absolutely false. But so now let's gradually move from archaeology to genetics, from description of current views on prehistory to our own data. But so far let's review major published data on genetic prehistory of Nadine people. So in 2012, David Reich has published the following admixture graph, which is actually a tree with admixture events modeled on this, with admixture event merged onto this tree. So these are branch points. Modern populations are in ovals, and simulated ancient groups are shown with small dots, and admixture events are shown by dashed lines with admixture proportions shown beside each line. These graphs are obtained in a rather complicated manner, which I will discuss in a few seconds. But what I wanted to say here is that he modeled first Americans in blue, African is an outgroup, then Han Chinese is here, and he modeled Chipewans, a northern Athabascan ethnic group, as a mixture of around 85% of first Americans and around 16% of a population which is related to Sakak, so the Paleo-Eskimo group. So he suggested that these populations come from the second migration wave, and these populations come from the first migration wave. And there's another model which for some reason does not incorporate Sakak directly, but it shows also the third migration wave, the Inuit and Yupik living in Chukotka. So models like that are obtained in the following way. First, all possible trees of 4 populations are assessed using a so-called F4 statistic, which is actually calculated using a very simple formula. At each locus, we subtract allele frequencies, minor allele frequencies, I mean, in populations A and B, so A and B, and multiply, and also subtract in population C and D, and multiply. And then average that product across all loci. Usually this statistic is applied to multi-locus data of hundreds of thousands sites. And if this statistic is not significantly different from 0, then we conclude that this particular tree is valid. There are 3 possible unrooted trees for 4 populations, and we can test all possible trees using this statistic. And standard errors are usually obtained by bootstrapping the data and recalculating the statistic for bootstrap data sets. If the statistic is significantly different from 0, it means that population X is significantly closer to either REF1 or REF2, and that depends on the sign of the statistic. If the statistic is positive, it would be close, for example, to REF1. If the statistic is negative, it would be closer to REF2. So this statistic allows to given a distant outgroup like an African population, it allows to assess relatedness of populations in a certain data set. So, for example, we take populations like modern or ancient genomes and calculate all possible F4 stats for this data set, and at the same time a model is built which incorporates not only sampled populations but also simulated intermediate groups, these intermediate black dots in the tree, and then another set of F4 statistics is calculated, but this time according to the model. And then these 2 sets of statistics are compared, and if statistics according to the model are not significantly different from the observed statistics, this model is considered valid. For example, here I've shown a model of mixed origin of modern Europeans, where Europeans basically are a mixture of 3 populations of first farmers that arrived at the start of the Neolithic, and Western European hunter-gatherers, and Siberian hunter-gatherers, which I've already mentioned in relation to Native Americans. So here we see that these Siberian hunter-gatherers contributed around 40% to first Americans, while they've also contributed to modern Europeans. So again, this kind of model was built using a large array of F4 statistics and comparing statistics calculated on the observed data to statistics calculated on the model. But another large and influential group of Esque-Willerslev in 2014 and in 2015 published 2 papers in Science, and they claimed that this story is not true, that Paleo-Eskimos had nothing to do with modern Nadine people. They applied another method called tree mix, which uses allele frequencies at genome-wide unlinked loci. So it operates on the same type of data as a forced statistic, but it uses different approaches, but the outcome is conceptually similar. So again, there is a tree of populations or individuals, and migration edges, so admixture events, are modeled on that tree, and each admixture event is associated with a certain admixture ratio, for example, 50 to 50%. And they observed that there is always an admixture edge between Athabascans, Nadina group, and Neo Eskimos. But they never observed admixture edges between Sakak, the reference Paleo-Eskimo genome, and Athabascans. But the problem of this method is that topology and migration edges are interdependent. For example, let's consider simpler trees from the same group which model the topology and admixture in Sakak and Neo-Eskimos and in Siberian group. And so there are various trees, the topology depends on the number of edges you put into the model. It changes with the more edges you add into the model, it changes the underlying tree topology. So in certain trees, Sakak branches closer to Neo Eskimos, which form clade with first Americans, and in this case there is a migration edge between Siberian group and Sakak. But if Sakak branches with this Siberian group, then there's a migration edge between Neo Eskimos and Sakak, but not between Sakak and Siberians. It kind of suggests that Sakak, that the underlying topology is not correct, and still the best topology has to be found. And adding more populations actually improves the topology. Now Sakak branches in one clade with Neo Eskimos away from first Americans, and now there's no admixture edge between Sakak and Neo Eskimos, or between Sakak and Siberian groups. But still there's a admixture edge between Athabascans and Neo Eskimos. So this example shows that interpreting remixed trees is rather tricky, and until reliable topology is found, there's no certainty in the inference of admixture events on the tree. But unfortunately, the group of Esque-Willerslev has based a lot of their arguments on remix analysis like this one. But anyway, let's start discussing our own results in view of these previous results. So what hypothesis we want to compare? We compare the hypothesis of Esquivilov's team that there was a massive genetic input from Inuit to Nadine, at least to northern Athabascans, which they've investigated. And they've also speculated about a mixture between Paleo-Eskimos and Neo-Eskimos. And alternatively, we consider the model by David Reich that there was only the admixture event from Paleo-Eskimos to Nadine. And I would like to say that using regular methods like admixture, we don't see the Paleo-Eskimo signal. We see the Inuit signal. For example, this bright green admixture component, it's characteristic for Inuit and Chukotkan people, and it occurs in northern Athabascans, but it does not. But the Siberian bright yellow component, typical for Sakak, does not occur even at low percentage in northern Athabascans. So we wanted to apply more sensitive methods, and we started with rare alleles. First paper on this method has been published earlier this year, and in this case rare alleles were applied to ancient genome. This method was applied to the investigation of ancient genomes from the British Isles, and they wanted to separate ancient genomes into two groups, into ancient Britons and Anglo-Saxons, and it was impossible using conventional methods, but it became possible using counts of shared rare alleles, and I would discuss that in detail now. So first I would like to describe our data set. We separated individuals into large groups, into meta populations, to obtain more statistical power, because so far the number of published whole genomes is not so high. So we had Europeans, Southeast Asians, and Western and Central Siberians, we called core Siberians, and other relevant groups. And first, I would describe the statistical approach. So it's rather simple. First, we restrict the analysis to loci at which minor alleles, so less frequent alleles, occur up to 20 times in the whole data set. If you have a data set of several hundred genomes, that would amount to 1 or 2% or less frequency of a minor allele in the whole data set of global populations. And the rationale behind this approach is the following. Most alleles used in other applications are pretty common, so they reach much higher global frequencies than few percent, but most of those alleles are pretty old, and for that reason, differentiating closely related populations and modeling events which happened not long time ago, like 1,000 years ago or 2,000 years ago, is rather difficult. So common frequent alleles lack resolution in this time window, and lack resolution for closely related populations like Germans or Czechs, for example, or Paleo-Eskimos and Neo-Eskimos, which are pretty similar. So to determine the source of admixture in the Nadine people to distinguish between the Paleo-Eskimo source and the Neo-Eskimo source, we need to apply a method like that. So first, we counted average number of sites at which an individual from population A shares a derived allele of frequency k with an individual from population B. So we just considered each site. We counted the number of non-reference alleles in population A at this site, number of non-reference alleles in population B at this site, then summed up across all sites in the genome. For that purpose, we used whole genome sequencing data because rare alleles are not included usually into SNP chip panels, and then divided the sum by the product of chromosome counts in population A and population B to normalize by population size. But unfortunately, further normalizing is actually needed because there are data sets specific biases. If genomes analyzed come from various sources, from various publications, SNPs in those genomes were called in different way, and that actually is a big problem. It introduces a lot of false positive signal, false positive rare allele sharing. So to cancel that out, we apply normalizing by another group. So for example, we take the Sakak genome and count how many rare alleles it shares with the Arctic meta population. So we consider all people of Chukotka, Kamchatka, and the American Arctic. We lump them together and count how many rare alleles the Sakak genome shares with the Arctic meta population, and then do the same for the European meta population. So we count how many rare alleles the Sakak genome shares with the European meta population and divide these counts. So actually, that's what is plotted here. These normalized allele sharing counts are plotted for each frequency separately to see the decay of signal for more frequent alleles. And here on top, the Siberian European relative allele sharing statistic is plotted, and here the Arctic European relative allele sharing statistic is plotted. Again, for each frequency class separately. And we see that Chipwans and Dakel, two Athabascan groups in this data set, two northern Athabascans represented by two individuals in each population, they stand out from all other Native Americans if we consider the least frequent alleles in the whole data set. And Sakak also stands out, but that's not surprising. This tells us that really there is a signal in the data set, and there's something going on in northern Athabascans. But so far we can't say anything beyond that. But let's sum up rare allele sharing counts in a certain frequency window from 2 to 5 in this area where we have the strongest signal. Let's sum up the counts and plot the Arctic European statistic and the Siberian European statistic for each population. And we see that each meta population forms a line on the plot. Here are Siberian groups and First American groups and people of the third migration wave, and also their relatives in Kamchatka and Chukotka. And surprisingly, Chipewans and Dakel, the northern Athabascan ethnic groups, they are very much shifted from the cluster of First Americans and shifted towards the Sakak genome. Again, unfortunately, we have only one good reference genome for Paleo-Eskimos. And we have no good ancient genomes for Neo-Eskimos, by the way. And here we zoom in the part of the plot to highlight Dakel and Chipewans. And where is it? Okay, so I actually had a different picture here. So actually on this slide, I've also simulated mixtures of First Americans and populations of the third wave or Sakak, because these statistics actually behave in a linear way under the scenario of admixture. So we can, using simple linear combinations, calculate expected statistics for admixed individuals with various admixture ratios. And actually, Dakel lies within an area occupied by individuals which might be formed by admixture of Sakak and First Americans, but not by admixture of this third wave group and First Americans. But Chipewans lie within the cloud of third wave mixtures, but for some reason I don't see this on the slide. So we had some indication that actually at least Dakel, at least this population might have been formed by admixture with Paleo-Eskimos but not with Neo-Eskimos. On the other hand, we've simulated admixture with modern First Americans, and moreover we estimated admixture of modern Inuit with modern First Americans. So actually ancient admixture of their ancestors could have drifted since that time point, and therefore position of mixed individuals could have changed considerably on the plot. And we needed to apply other methods to tackle this problem. Actually, we applied similar approach to yet another type of data, to autosomal haplotypes. As you know, there is active recombination going on in our germline, but anyway, there are chunks of our genomes which are relatively stable over a time period of at least few millennia. So these chunks can be used to compare genomes, make inferences about population trees, to infer admixture, and even to date admixture events and population splits. So now most common program for analysis of autosomal haplotypes is Chroma Painter. We calculated haplotype sharing statistics based on an all versus all co-ancestry matrix constructed by this program. And I plan to explain that approach, but I would not go into the details. I would just say that we calculated the length of shared haplotypes in centimorgans, again between a Native American group and the Arctic or Siberian meta population, and normalized by similar haplotype sharing statistic for the European or the African meta population. And we obtained two dimensional plots which essentially look similar to the plots I've shown for rare alleles. And again, we see that some northern Athabascan individuals are shifted from the cluster of first Americans, some but not all. Here we have only 2 Dakel individuals and many Chipewyan individuals. We see that most Chipewyan individuals are not different from first Americans, but there are Chipewyan individuals which lie outside of this cluster. Unfortunately, in this case, we don't have any measures of standard errors. And again, my simulated mixtures are gone on this slide. But the message is the same, that these individuals lie outside of the area of simulated mixtures that would result from the third wave mixing with the first wave. And the same plot for another data set, again showing the same picture, but this data set contains more branches of the Nadine language family. It contains various northern Athabascans and southern Athabascans and Tlingit, and at least one individual from each of those branches. It occurs in this outlying cluster, and only one individual with another language affiliation occurs in this cluster. So this cluster is composed mostly of Nadine-speaking individuals. Okay, and here we calculated rare allele sharing statistics for each population versus Sakak, and for each population versus Arctic and Siberian and African, and normalized in the following way: Sakak by African and Arctic by Siberian. And we see a crucial point that Dakel that they lie within the variability of first Americans according to the Arctic versus Siberian ratio, but outside of the variability of first Americans according to the Sakak versus African ratio. So it means that they have elevated Sakak ancestry, but their Arctic ancestry, their third wave ancestry, is not beyond the range of other Americans, which is suggestive that actually there was admixture with Sakak, but not with the third wave, or at least the admixture with Sakak was more extensive than the admixture with the third wave. And similar plots were made also for the haplotype sharing stats. And again, we see the same picture, that there are individuals which lie outside of the first American cluster on the Sakak axis, but not outside of this cluster on the Arctic versus Siberian axis. And it delivers the same message here again, another data set, and we see that there's a cluster of 13 Nadine individuals and 3 other North Americans, which are outliers on the Sakak axis, but most of them are not outliers on the Arctic axis. And the message here is everywhere the same. So we applied model-free intuitive approaches to the following types of data: to rare alleles, those occurring at 1% for frequency in the data set and less, at biallelic SNP loci, and to autosomal haplotypes composed of biallelic SNP loci with relatively frequent minor alleles, so those coming from SNP chip data. And the results are highly consistent. Then we applied a further set of methods very recently developed by the team of David Reich, QP-Wave and QP-ADM. These approaches are based on unlinked biallelic SNP loci, and they allow to infer percentage of admixture in certain populations. So in addition to rare allele data and autosomal haplotype data, we decided to work on standard data, but using these relatively novel methods. And these methods again operate on large arrays of F4 statistics. So they compute all possible statistics of the form American 1, American 2, outgroup 1, outgroup 2, where outgroups are the following populations from number of world regions, and these are all American populations in our data set, Inuits and Athabascans and North Americans, South Americans, and Sakak. And we take certain combinations of Americans and calculate all possible F4 stats versus outgroups and see whether this matrix of whether there are different vectors of F4 stats in this set, whether populations we take come from 1, 2, or more streams of ancestry, whether they have different patterns of relatedness to the outgroups. So basically we try to see whether 2 or 3 populations we take, whether they are related to the outgroups in profoundly different ways or not. And here we took Mayans as a representative of South Americans, and we took a range of other populations, Sakak and 3 Inuit groups, and also Athabascans and Tlingit. And if we take Mayans and, for example, to Tlingit, the program says that there are 2 migration waves in this data set. It means that Tlingit and Mayans are related to outgroup populations in a different way. It means that their F4 stats are rather different, not a single F4 stats, but there are sets of F4 stats associated with Tlingit and a set of F4 stats associated with Mayans are profoundly different. And then we add the third population. We consider Mayan, Sakak, Dakel, and still this set of 3 populations has only 2 migration waves. It means that we can try to model Dakel as a mixture of Mayans and Sakak. And indeed, we apply QP-ADM program for this purpose, and we see that Dakel can be modeled as a mixture of 87% Mayans and 13% Sakak. But what is striking here is that subgroups of Nadine behave in different way. We see that Dakel and 2 groups of northern Athabascans can be modeled either as a mixture of Mayans and Sakak, or as a mixture of Mayans and Alaskan Inuit, and also East Greenlandic Inuit in one case. But that's not the case for southern Athabascans and for Tlingit. It means that probably there's no Inuit ancestry at all in these groups, in Tlingit and in southern Athabascans, but there might be both Sakak and Inuit ancestry in northern Athabascans. And when we return to the archaeological picture, we will describe that this result makes perfect sense, because Tlingit have split from other Athabascans and occupy this position pretty far from Inuit a long time ago, more than 2,000 years ago probably. And we know that southern Athabascans have probably started their way south 850 CE, long before the Tule culture appeared in Western Alaska and could interact with Nadine people. So it's not surprising at all that there's no trace of Inuit ancestry in Tlingit and in southern Athabascans, while there is some trace of Inuit ancestry in northern Athabascans. And moreover, using the same QP wave and QP-ADM method, we've established that some groups of Inuit are indeed mixed with Paleo-Eskimos. First of all, the only Alaskan Inuit individual in this data set, and to less extent the East Greenlandic Inuit, but not the West Greenlandic Inuit. And finally, we applied a model-based method to infer population splits and mixtures based on rare allele sharing patterns, and to date population splits and mixtures based on rare allele sharing patterns. I wanted to explain how this works, but I would skip that, and I would just show our final model. So that's a pretty complicated approach which involves stepwise addition of branches onto the model, and then stepwise addition of migration events, and each time assessing whether the model fit improves. And our final model is the following. So there is a simple tree with Europeans as an outgroup, and Southeast Asians, Siberians, and the third wave, Athabascans and South Americans. So 6 populations, actual matter populations composed of several populations each, and a number of migration edges, but not all of them are shown here in this figure because most of them involve Europeans and are not informative for our discussion. But importantly, there is an edge, bidirectional edge, because we try to estimate the admixture in both directions. But most admixture is going from the Siberian stem into an ancestor of Athabascans around 6.57 thousand years ago. Unfortunately, there's no Sakak genome on this tree because it's only one individual, and it's difficult to directly incorporate into this model. But when we try to map a branch point of the Sakak genome onto this tree, we see that it falls either here on the American stem or it falls on the Athabascan stem after the admixture event. So we might hypothesize that this admixture event actually involves a ghost population which split off the Siberian stem and then gave rise to Paleo-Eskimos and then admixed with Athabascans. And also we see a much later admixture event around 500 years ago, admixture event between the third wave between Inuit and Athabascans. But that was probably a bidirectional admixture event. And remarkably, the dating we obtained for these crucial events, it is in agreement with the archaeological record in Siberia. For example, we know that the Alach archaeological culture has appeared around 6.5 thousand years ago, and it's generally believed that this culture gave rise to Paleo-Eskimo ancestors which migrated to America. And this corresponds nicely with the date of the admixture edge between the Siberian stem and the Nadina stem. So now we think we know the answer to the question formulated in the middle of the talk. We know that there was definitely admixture between the Paleo-Eskimo branch and the Nadine branch, but additionally there was later admixture of newly arriving Inuit and local Paleo-Eskimos, and probably also admixture of Inuit into northern Nadine people. And the resolution of this question took so much time because these events happened not so long time ago, because they happened later than 5,000 years ago, and because Paleo-Eskimos and Inuit are relatively similar, so it's not easy to distinguish the sources of admixture in this case and the dates of admixture using standard methods and standard types of data. So here are the conclusions: that the coastal interior boundary was probably permeable from the beginning. Using yet another method, we've dated the Paleo-Eskimo Nadine admixture event to 4.6 thousand years ago. So probably it started immediately upon the arrival of Paleo-Eskimos around 4.8 thousand years ago. And after the divergence of Tlingit and southern Athabascans, the northern Athabascans, which remained in the north, have admixed with newly arriving Inuit. Some, but not all, Inuit also admixed with Paleo-Eskimos. It's unknown whether Nadine have inherited their language from first Americans or from Paleo-Eskimos, and we would never know. But potential connection of Nadine languages with the cat language, as hypothesized by Edward Vida, and genetic proximity of cats and Sakak we observe in some of our analyses, like in rare allele analysis, are highly suggestive that despite the fact that the Nadine people have inherited most of their genes, up to 80-90% of their genes, from first Americans living here, they probably have inherited their language from Paleo-Eskimos. But again, that's extremely controversial, and we would never know which language they spoke. So I would like to acknowledge funding from an internal grant by the University of Ostrava and from the city of Ostrava, and also other places where I work in České Yevice and in Moscow. And I would like to acknowledge all sample donors in the Yenisei area. And I would like to acknowledge members of my team, my PhD student and my postdoc. He's much older now. These people did most of the work, along with Stefan Schiffels from Max Planck Institute for the Science of Human History in Jena. He's my principal collaborator and the developer of RareCall. Also, I would like to thank Edward Weider, the author of the Danny-Yeniseian hypothesis, who is also a co-author of our preprint, and David Reich and Johannes Rauser, our big bosses. So thank you.